functions. I got rid of one of them, your A squatters. So there's two functions to find f and g, and we need to find first of all f 1.5. So what do we do to find f 1.5? Anyone? DNA.
You substitute 1.5 and like the f.
Yeah, exactly right. So what would that give us?
1.5 times 2 is 3 plus 5.
Oh, so so 5 plus.
Oh, plus 2, 1.5.
Yeah. Which is lovely. And then part 2, Shayla, what we're going to do for part 2? Okay. Oh, okay. G6. Wait, no, hold on. We're doing this. G6. Okay. So tell me first of all, what does that mean?
Substitute.
Mia.
It's like 6.
Yeah. So what's that? 10 to 6. You can do that without. 4. And then square root it. 2. Teamwork makes the dream work. All right. Now this question says, given that FA equals 2, find A. What do we do here? Mia.
5 plus 2a equals 2.
Okay, let me just hold there. Is everyone happy with that? You see how this one is different?
Yeah.
Yes? So they told us that the function f, when a is substituted, is equal to 2. And it's a common mistake that people make. They just see a number and they get merrily chuck it in to substitute it for the x. But this one's different. Okay, thank you. Now let's keep going.
2a equals -3. A equals -3 divided by 2.
Lovely, and we can leave it as an improper fraction. No.
Where did we get 5?
From the original function.
Oh, yeah. Oh, sorry.
Yeah. Dinah, what would I do for the next question? It says, given that GB equals 5, find B.
10 equaling under the bracket equals 5.
Lovely. Can we solve this one, please? How do we get rid of square root? Yep, so we will have 10 minus b equals 5 squared. Lovely, because that's the opposite of square rooting. I'm sorry, how do we? Oh, no, that's, remember I just said that people fall into the trap of seeing numbers and they want to chuck it in place. So it's a different kind of question. So this one has the 1.5 inside the bracket. This one says that FA equals 2. Okay, so your function is equal to 2. You need to find this missing number. Obviously, favorite function. Okay, so you see how it's written differently there. Okay, so that's in a different style. All right. Sorry, Donna, carry on. Shush. Yeah. Lovely job. All right, the functions f and g is defined as follows. Then find fg3. So what's happening here? What's the deal here? I should get a few more hands. Emily. Pardon? Nice. Which one are we going to do first? G. Perfect. So remember, when there's numbers, actually that's easier than when it's letters. Okay? because all we have to do is stick the numbers into the functions and then follow that answer through. So that we're going to, for FG3, we're going to first of all find G3. Okay, so someone needs to turn their phone off. So G3, we would substitute 3 into this bad boy, so we'd have 3 squared, which is usually 9. Okay. How would you know? You don't know, it's not, you don't have to put the brackets in, you just have to know to find the one closest to the brackets first. Okay? Now that means that we are then going to stick this value into here. So we're going to find f of 9. Okay, so we found g of 3, we've got an answer of 9. So that answer is now going to go into f. So we're going to have 1 over 9 minus 2, which is 1 over 7. There we go, finish. Okay, so that's FG3. So that's part 1. And part 2. Well, no real prizes for this one, because it's obviously the other way around, so we know we need to do the other one first. Mia?
1.5 minus 2 squared.
Hang on. 1 over 1.5 minus 2.
And the whole thing is squared.
Alright, I'm just going to go base steps. That's alright for you. So we've got 1 over 1.5 take away 2. What's 1.5 subtract 2? So we've got 1 over negative 0.5. Now that's looking a bit nasty, isn't it?
Sorry.
So the whole thing is negative. I've got 1 divided by a half. Are we all happy with that? Yes. So I've got 1 on the top and we're dividing by a half. I put the negative in front of it. When we divide by a fraction, what happens? Keep changing it, so we're going to multiply by its reciprocal, yes? So we've got negative 1 multiplied by 2 over 1, which gives us negative 2. We all comfortable and excited and happy about that? No. Oh, right, let me pause 1 moment. Alright, so we've got negative 2, then we're going to stick that value into g, so we're going to now find g of negative 2. So it's going to be negative 2 squared, which is 4. Now, if you heard Mia say we're going to square this straight away, you're very welcome to just do all in one if you wish. Sometimes if they're more complicated functions, it's nicer to get one answer and then substitute into the other. Okay? Pardon? No. Right, so that's part 2. Now on to B. Express the composite function fg in the form fgx. So now they want to keep it with the x. So we're finding fgx. And remember, what is that? Which order do we do it in, Emma? So what we get? Which order are we going to do it? So G goes in. So remember, we're looking at this baby here. So what are we going to write instead of 1 over x minus 2? Okay, so we've said that g, which is this, is going to replace any x's in the f function. So what are we going to write? Yeah. So what will we write? Awesome. That's it. Yeah?
I just have a quick question about earlier. So with
I'm going to pause that. So that's our final question. Says which value must be excluded from the domain of fx. Okay, so they're looking at fx. They want to know which value must be excluded. So looking at fx, what do we know about functions that look like this? Gabrielle, do you remember? What do we know about functions that look like this? Why must sometimes we limit the domain? Okay, that was the page. So why must we limit the domain? I see a couple of hands up. Lily, do you remember why we have to limit the domain?
No. Oh.
Helen? Negative, we can have negatives on the bottom. We can't divide by 0. Okay, so here I've got a fraction, so I've got something on the bottom. So we have to find which value of x would make the denominator 0. So in our case, which value would that be? Casey? 2. Good. So we all happy with that? X equals 2 must be excluded.
Is that how you should write it? You can't write x.
Well, I would suggest write x equals 2 must be excluded. If you wrote x cannot equal 2, you'd probably be fine. It's just the question says which value of x must be excluded. And so they're wanting the value of 2. So if you say x cannot equal 2, I don't know, it's just a bit risky. I don't want to risk it for a biscuit and lose marks. Okay.